Okay, hey guys. So we're going to be doing some practice problems with oxidation reactions specifically. So in on the slide, it asks you to predict the product of the following reactions. So let's go ahead and get going. So I'm going to look at this first reaction here. It shows that I have a molecule that looks like a secondary alcohol. So I'm going to write secondary. When we have a secondary alcohol, we remember we go to a ketone, but let's look back at the Y, okay? So what I like to do for these reactions, especially when I was first learning, is I like to draw in the hydrogens that are going to be oxidized. So here we have one hydrogen on the carbon of the alcohol. So that means I have one oxidation reaction that can occur. So I need one more carbon oxygen bond than I already have. So I'm going to go ahead and circle the two hydrogens that I'm going to lose, draw out my carbon chain the same as it was, minus those hydrogens, and then replace those hydrogens with a double bond between those two atoms. So now I have a ketone, secondary alcohol to a ketone. Let's go down to the bottom one here. So now I have a primary alcohol. We only have one carbon connected to our carbon of the alcohol. Do the same thing. We're going to draw in any hydrogens on this carbon here. So now I have two hydrogens on this carbon. So I have two different opportunities to do a oxidation or add more CO bonds. So these two hydrogens are going to be what's reduced in our first reaction, but then we need to do a second oxidation. In our second oxidation, we're going to get rid of our third hydrogen, and we need water. So we're going to assume water's in these reactions. We don't need to necessarily write that in order for this to fully go to a carboxylic acid. But I'm writing the water there just so that I know, I remember what's going on. So I'm going to draw my carbon chain minus my hydrogens. My first oxidation gets me to an aldehyde. Let's go ahead and write that out. Gets me to an aldehyde. Then let's do it like this. Then I get rid of my other hydrogen that I have here, and I have water associated, which takes the other hydrogen, and I'm going to replace that hydrogen in my structure with an OH bond, or I'm sorry, CO bond. My bad. So now I have a carboxylic acid. So this is going to be my final answer, is this carboxylic acid. Great. Okay, our last one here. Let's look. We have a tertiary alcohol. Goodness. A tertiary alcohol. So I'm going to draw in any of my CH bonds that can be oxidized, and there are none. So that means that we have no reaction because there are no CH bonds to be oxidized. Okay, so we have one other practice slide. It says, give the primary product of the reaction of 2-propanol when it undergoes oxidation and dehydration. So 2-propanol, we have prop, and then at the 2 position, we have an alcohol. It says 2-propanol. We're going to undergo an oxidation reaction. So I need to draw my O in brackets to symbolize oxidation. And then I'm going to draw in my hydrogen that's going to be oxidized. We have these two hydrogens that we're going to lose. And our final product is going to be with a double bond where we lost those hydrogens. So this is my answer for the first one. The oxidation of 2-propanol is going to make 2-propanone. There we go. Or acetone is the real name of that molecule. Okay, dehydration. So we start with our same molecule, 2-propanol. And remember, recall back from just a couple videos ago, dehydration, instead of removing the hydrogen, two hydrogens, we're losing water. Hydration, losing water, dehydration. So I'm going to draw on the carbon next to my alcohol which hydrogen I'm going to lose. So I'm going to lose the OH and the H next to it. So then my final answer, we need our reagents. So we're going to have H plus and heat. I like drawing heat as delta because it's faster, but you can draw either. And then we eliminate, so we form our double bond where our two things were originally. Our OH and our H were originally. So just by changing those reagents, we can get different products from the same molecule. Okay, that was our practice, and we'll keep going in the next video. See you guys there.